Alrighty, welcome everyone to today's workshop. Today we'll be talking about advanced CI/CD for AWS. And of course, we're going to be using Pulumi and GitHub Actions. My name is Diana Esteves. I am a solutions architect here at Pulumi. And with us, we have Ben.
Hi everyone, I'm Ben. I'm Director of Product for GitHub Actions over at GitHub.
All right, so today's agenda, we are first going to do a quick recap on Pulumi and GitHub Actions. This is an advanced workshop, so there is already an expectation that you have some understanding of these two technologies. If you don't, that's okay. We'll try to go over them as quickly as we can, just so that you have a good baseline to continue with the remaining of the workshop. It is going to be very demo focused. We have a lot of demos for y'all today. The first one is taking an existing pipeline. We are going to be adding OIDC. So this is going to be both for AWS as well as for GitHub. The next demo is going to be taking our pipeline and adding compliance. This is going to be, again, for AWS CIS compliance in particular. After that, we're going to move on to another demo in which we are going to introduce drift detection to our pipeline. And this will be achieved via a GitHub Actions cron job. Last but not least, we're going to talk about Pulumi deployments, and we're going to configure those so as to create a temporary environment in which you can test your features as you're working on them and have that environment be automatically destroyed once you close your pull request. All right, and of course, we'll have time at the end as well for any additional questions. Okay, so with that, let's go ahead and talk a little bit about what Pulumi is. So Pulumi, it's a lot of things these days. Our bread and butter is infrastructure as code. And with infrastructure as code, it allows you to define just about any cloud resource out there today using your favorite programming language. Pulumi supports Node.js, Go, Python, .NET, Java, and if you want to, YAML as well. So you can use any of these programming languages to define all of your infrastructure. Today, we'll be using AWS. In particular, we'll be defining an S3 bucket and a Cloudflare CDN using TypeScript. Again, it is not the only integration that we have. I think last time I checked, we have over 170 different integrations out there. So you could think about all your different technologies that you use today and having the ability to define all those resources in a declarative manner using your favorite programming language. Two of my favorite things about Pulumi: number one, open source. We use an Apache 2.0 license. And the second one is we have a Pulumi Cloud free tier. It is free forever. You can have your pet projects in there. It is what I do. With Pulumi Cloud, what that means is that Pulumi Cloud is going to manage the state of those cloud resources on your behalf, which is one of the most challenging things to do when getting started in the infrastructure as code space. So we're essentially offsetting the hardest thing to do and telling Pulumi Cloud to handle it for us. So this is what we will be using today. You do have an invite to, I think, a 14-day free trial of a Pulumi Cloud organization where you can take advantage of all of the business critical features that we have there. So certainly encourage you to go ahead and take advantage of that. All right, so Pulumi and CI/CD, these two tend to go hand in hand. We offer a lot of different ways of integrating your existing CI/CD pipeline along with Pulumi. Of course, today we are going to be heavily focused on GitHub Actions because that is popular and it's great. I love it. It's a great way to get started with CI/CD, all the way from your early pet projects to anything production level. So with Pulumi, what we're going to do is essentially we want to preview our infrastructure, right? So we want to get an idea of what it is that we're going to deploy onto the cloud whenever we commit on a pull request. And we want to go ahead and update or create or delete the actual resources once we merge our pull request to our target branch, in our cases, it's just the main branch. There's two particular GitHub Actions that we'll be using today that are offered by Pulumi. So we'll see those here shortly. And then we're also going to talk a little bit about Pulumi deployments towards the very end. Alrighty, so with that, I am going to hand it over to Ben, and he is going to tell us all about GitHub Actions.
Cool. So good morning, good afternoon, good evening, depending wherever you are. Thank you for the opportunity to chat to you for a little bit. I'm Ben, I work at GitHub, and I want to chat about GitHub Actions. So most of you, a lot of you may have tried it. For those who haven't, GitHub Actions is the built-in automation tooling in GitHub. It's mainly used for CI/CD, but people use it for a lot of automation for a lot of other things. If we can go next slide, please. Okay, can I control the slides? If I click, does that work? Yes, I can actually do it as well. Okay. So GitHub Actions as an automation tool, and generally with CI/CD, is there to enable developers to automate away a lot of their pain, a lot of their boring day-to-day things, and allow you to automatically build, test, and ship your code to production. It's an advanced workshop, so hopefully I don't need to teach you too much of that. A lot of what we focus on in GitHub Actions is how we can not only speed up what you do, but also do it securely. And GitHub's very much invested in how we can do secure builds, secure tests, and secure deployments, and really how we can make that just easier and remove as much of that burden as we can from everyone else who's trying to work with Actions. We've got sort of three themes within Actions that we're focused on, and I wanted to just talk about some recent releases in each of those themes because I've got you as a captive audience. So of course, I'm going to talk at you. The first thing that we're focused on in GitHub Actions is just the experience for developers. How can we make the developer experience better? We've had a few ships in this area recently. We shipped Actions Insights. So at the organization level, you can now view how many minutes people have used, how much people have used your workflows. And we're also going to be adding to that things like failure rates. So you can understand and dig into where your sort of majority of your test failures coming from, where are you wasting sort of minutes, where are you wasting that money or that time with high volumes of flaky tests or whatever. We've had an improved sort of deployment dashboard view. So from that CD side, so again, if you're doing stuff with Pulumi and you're deploying, you can look at how those deployments are working, when it was deployed, what was deployed. And then we've also released our VS Code extension to allow you to do local linting of your workflow YAML, which is very cool. Next is how we do fast. So fast and secure. So from the fast side, we've got a bunch more stuff coming here, which I'm very excited about. More recently, we've been focused on just adding more SKUs, which is kind of cool. So we added ARM to our paid tier, and we'll be adding ARM runners before the end of the year to our public repos for free. And you'll be able to use your private repo entitlement minutes for that as well. We added M1 Max as free in public repos earlier this year, and you also can use your entitlement minutes for those. And then from the security side, for those who are interested in things like Azure, we've added secure networking with Azure. We'll be doing, again, more in that space around network security and sort of that enterprise control as well. I only had 2 slides. I forgot one of my slides. I guess I merged it into one. The other side of that is very much how we do more advanced things in build performance. So we've got a bunch of new stuff coming there as well around how you can pre-warm your machines, pre-include things on the machines to make that faster. And then going further on the security side, we're also going to be going much further down to the SLSA secure framework standards to see how we can make that more turnkey. We released sort of early this year as GitHub, we released SIG store in GitHub, so you can sign on and test your own packages. We'll have a bunch more stuff around how we actually sign on and test everything you're using in your entire Actions workflow to produce that sort of end-to-end provenance. So if you want to chat sort of secure supply chain stuff, I'm always interested in that. And that's what I've got, because you didn't really come here for me to pitch at you. You came here to learn about how to do this with Pulumi, so I'll now be quiet.
Thank you, Ben. That was great to hear, and especially all the cool new things that are coming down for GitHub Actions. I mean, it's already such a great popular tool out there for so many developers, and it's just getting better. So definitely great. As Ben said, if you have any follow-up questions, just feel free to post them here in the chat, and we'll be happy to get an answer for you. Yeah. So coming back to the slides. We have our infrastructure CI/CD pipeline. So what you see here is actually what we ended up with in the getting started version of this workshop. Again, if you weren't here for that, we're going to go over everything we did in the next minute or so. Alrighty, so a infrastructure CI/CD pipeline has three major stages. The first one, or the idea behind it, is that you have your application code, right, typically in a GitHub repository. The idea is that you also want to include your infrastructure code along with your application code. This is typically in a separate folder within your GitHub repository. So in our case, it's just a folder called infra. Our application is very, very trivial. The focus is on the infrastructure, not the application. The application is just 2 HTML files. It's just saying something like hello world. The infrastructure itself is a S3 bucket that then takes those HTML objects and upload them on an S3 bucket. And then there is a Cloudflare CDN in front of it just to make it a little bit more interesting. And then, because this is a pipeline, we, of course, want as much automation as possible, which means that stage 2 of our pipeline with test and commit, right, we want that to happen automatically. For that, we have GitHub Actions. Our GitHub Actions is going to conduct the equivalent of a Pulumi preview on our behalf to make sure that everything that we have defined in our TypeScript Pulumi program works as expected. Once we go through this cycle, right, we go between development infrastructure and then test commit multiple times. Once we feel confident, we will technically go ahead and merge that PR, which will trigger the third stage here, which is our build and deploy stage. And in this GitHub Actions, we will configure is essentially the equivalent of a Pulumi up command. The Pulumi up command is the one that's responsible for actually deploying the resources that we have specified in our Pulumi program. I am also going to show you everything we have here very shortly. But again, the idea is that you are defining application code and infrastructure and then automating all your CI/CD pipeline stages with GitHub Actions. Alrighty, so with that, we are ready to get started with our demos for today. All of these demos, they tend to align a lot with what we call Pulumi for platform teams. Pulumi, right, technically started out as an infrastructure as code solution. We are very good at that. Nowadays, we also have a portfolio of other peripherals that really help platform teams. So we'll get to cover some of those here today. Starting with adding OIDC. OIDC, it's your OpenID Connect, right? The idea is that you want to request a temporary credentials against someone you trust to be able to do something for a short period of time, as opposed to having long-lived static credentials, which is not really a best practice. So the idea or the goal for this demo is adding OIDC, and the goal of that is to have the ability to essentially remove secrets from our pipeline, because we want to have more of an externalized secrets management solution that is the one handling all of those secrets, and we're merely just consuming them as opposed to having them live within our pipeline, which can lead to potentially other things. So again, the goal is to be able to remove secrets from our pipeline. So the screenshot here may look very familiar for a lot of you. It's something that you see very commonly in a lot of places, in particular having hard-coded AWS credentials to be able to deploy resources onto your AWS account. However, we want to take a slightly different approach that's more secure. We want to instead be able to request those credentials on demand. How we're going to do so, we are going to use something called Pulumi ESC. Pulumi ESC stands for Environments, Secrets, and Configuration. It is part of the Pulumi Cloud. It's a managed service on Pulumi Cloud. And the idea is that now you have the ability to centralize all of your secrets management for both application and infrastructure and really anything in between. So the idea with Pulumi ESC is that we are going to store and configure all of our secrets in this one location, and we're then going to have a consumption interface that we can go ahead and share with whoever needs it. In our case, it's our pipeline and our Pulumi program that need access to those credentials. So a couple of additional benefits that Pulumi ESC offers, it's the ability to compose environments. So you can have this idea of inheritance, where one environment can inherit values and secrets from another environment. And dynamic secrets, which is what we will be configuring here shortly. Again, with dynamic secrets, right, the idea is that we're now pulling secrets from other systems or generating secrets on the fly, as is the case with AWS OIDC, which is your OpenID Connect. And again, configuring this, yes, it takes a little bit of effort, right? It takes a couple of minutes to get it together, but the idea is that it's a one-time effort, right? Once you configure this environment, you can go ahead and share that environment with any consumer that may require it. And that's exactly what we're going to do here next. So with OpenID Connect or adding OIDC with AWS, this is what we're going to do next. In our AWS account, we have to configure both an identity provider as well as a role under our IAM service. Once we have those resources created, right, we can then reference them in a Pulumi Cloud ESC environment. Once I reference that and I create my environment, I can then share my environment with my Pulumi program. And my Pulumi program, right, is deployed by us in the terminal as we're testing it and playing around with it, and is also deployed by our CI/CD pipeline. So with that, I'm going to go ahead and switch over to my Visual Studio Code, where we are going to configure exactly what we see here on this diagram. Now, to configure the AWS resources, right, there's multiple ways to go about it. I can go the old school way and do my ClickUps approach, right, where I can go into my AWS account and create these resources manually and configure them. And sure, that'll work, but we are infrastructure as code. So instead, we are going to use a Pulumi template to define and deploy these AWS resources on our behalf. Alrighty, I do see a couple of questions here that have come up. OpenID Connect, yes. ESC is currently in preview. It is expected to GA soon. While it's in preview, it's completely free to use by anybody that has an individual Pulumi Cloud account. So it is currently free to use. Alrighty, so let me go ahead and switch over to my screen. So hopefully y'all are able to look at my Visual Studio Code. So let me just go over this very quickly. So I have my application. Again, it's just two very trivial HTML files. It could be something a lot more complicated. And then I have my infrastructure folder, which is what we are focusing on today. And then here I am declaring my AWS resources using TypeScript. So I have an S3 bucket where I am uploading a couple of files. And then I have a folder that points to the contents of my app folder. And then the CloudFront CDN in front of it, just to make it a little bit more fun. So this is where we are today. And if I look at my existing GitHub Actions workflows, so we have two of them, right? Remember, we want to do a preview on a branch, and we want to do an up on our merge. So here is where we ended up last time. This is a workflow that's going to trigger every time I do a commit on, say, like a feature branch. And essentially, we want to get rid of this the idea of having secrets stored in our pipeline. So these are all the steps that I'm currently doing. And the only difference between my branch and my main is really just my command, where I am actually deploying my resources versus where I am obtaining a preview of my resources. So that's where we are currently. And now we are going to introduce and create a Pulumi ESC environment so that I can go ahead and remove those AWS credentials from my pipeline. So the first thing I'm going to do is, again, there are multiple ways of creating the resources that we need for AWS, right? So we need the identity provider, and we also need a role. But because we are using Pulumi, we're going to go ahead and leverage a template that will help us create those resources on our behalf. So I have a template available in our examples repo. There's hundreds of examples there that can help you bootstrap your development with Pulumi. So definitely urge you to go ahead and check those out. There's a lot of pretty interesting projects there. Then I am going to create a new Pulumi project, and I'm just going to go ahead and call it AWS OIDC because that is what we are configuring. Now this is going to walk me through a wizard, so I'm just going to go ahead and use all my default values. I am using NPM and US West 2 region. I'm going to use just the default name. All right, so all of the defaults will work just fine for what we're doing here today. The next thing that's going to happen is just going to go ahead and install any dependencies that I may need. So we'll give that a second to work. Now let's take a look at what we just copied over, right? So this is our new project. And in this Pulumi program, we are defining a IAM role, right, which is what we need. And I am also defining a ESC environment. So all these resources are going to be deployed when I run my Pulumi up command. So at this point, I do not yet have my OIDC configure, which means I do have to provide AWS credentials for now in order to be able to run Pulumi up. So once that's there, I should be able to run Pulumi up and deploy the resources that I have defined in my AWS OIDC Pulumi program. So this is how you can go ahead and deploy those resources. Now, for my AWS account, I actually already have these resources deployed. AWS only allows you to create one identity provider for Pulumi Cloud per AWS account. So for my use case, this will actually fail because those resources already exist. However, I still want to go ahead and show you what you would do if this is the first time that you are setting up these resources. So again, mine will fail because all these resources already exist in my environment that I am using today. Okay, and here is my warning. So I am now going to switch over to my AWS console just so you can see what those resources are in my AWS. So here is my IAM. And in my IAM, the first thing that it created was my Pulumi Cloud OIDC identity provider. Yours will look something similar. You do have to provide an audience that needs to match your Pulumi organization. So I'll show you this shortly. And the other resource that should have been created is a role. I have a lot of roles here, but this is the one that was created. So in this role, you can see the trust relationship. Again, this is a reference to the name of the Pulumi organization that we are using today. So now that I have these resources in my AWS account, I can go ahead and configure my Pulumi ESC environment. So I'm going to go ahead and show you what that looks like. So this is Pulumi Cloud. Within Pulumi Cloud, you have environments option. As you can see, it is in preview, so we can all use it as much as we want to for free. So here is my environment, and the syntax for the environment, you can read a little bit more about it in our docs. So I can share that link. But this is what it looks like. Essentially, I have a configuration where the role has to match the role that I just created in my AWS account. And then I can go ahead and define those 3 variables that you saw in your workflow file just earlier. But now this is being done dynamically. It's being requested on demand, and then these variables are dynamically loaded. So this is how you go ahead and configure it. All right, great. So now I have my ESC environment. So now I have to tell my Pulumi program, hey, go ahead and use this ESC environment so that you can have access to an AWS account. So that's the next thing that we're going to do here. So I have my Pulumi program. In my Pulumi program, I have a dev stack. And in my dev stack, oops, I already went ahead and added my environment reference. So with this reference, what this means is that my Pulumi program now has access to AWS credentials that will get generated on demand. Alrighty, so with that, let's go ahead and modify. Okay, so yeah, so now that we have that, let's see. If I were to do a Pulumi preview on my dev stack, right, that is going to go ahead and make sure that everything that I have, or see what changes are expected, if any. And I would not have been able to run this command successfully unless I had access to my AWS account, which I now have. So this is what I mean by it's a one-time configuration. So now that I have created my ESC environment, I can reference this environment in pretty much any Pulumi program that makes sense, as well as many other ways of accessing those credentials. Alrighty, so let's go ahead and come back to the slides and see if we have any questions so far. Okay, so essentially this is what we just did. Alrighty, and then so that was AWS, and now there is also GitHub. So if you recall, in our pipeline, we had a Pulumi access token that we have to hard code, essentially. So what we're going to do is now configure our Pulumi Cloud account with GitHub OIDC. And we're going to do so using the Pulumi auth action, so that the Pulumi auth action is going to go ahead and request a token at runtime from our Pulumi org to be able to access the stack that we have defined there. So I'm going to go ahead and switch over and show you how to configure GitHub for OIDC. So let me go ahead and come back to my screen here. Okay, so we just got here. So in your Pulumi org, under settings, you can head all the way down to OIDC issuers and register a new issuer. So here I have GitHub Actions, which I configured a little while ago. So the way this is configured, and again, we have a lot of documentation on what each one of these mean. It's similar to what you just saw on the IAM role. So you need an audience and a subject. So the audience is really my Pulumi organization name. So this is the name of my org is Pulumi Sandbox Diana. And as well as a repository that's given permission to request my token, right? So I have to be explicit on what am I allowing to request my token. So this is the configuration that's needed on the Pulumi cloud account in order to allow GitHub to request tokens on your behalf. So once this is configured, we can go ahead and take advantage of our GitHub action, Pulumi auth GitHub action. So let's go ahead and update our workflows so that they can now take advantage of our new configuration, right? So we configure ESC, and we also configure GitHub OIDC. So we should effectively be able to get rid of all these secrets from our pipeline. In order to request a token, we're going to add a step to our workflow, and the step is going to go ahead and request a token from our Pulumi org. The Pulumi org, again, this will change depending on which one you're using, right? So mine is Pulumi Sandbox Diana. So now that I have a token, I can go ahead and do my Pulumi preview command. I'm also going to update my merge workflow. So again, I no longer need these because we just configured that. And I do need to be able to request a token. So I'm going to go ahead and change that in here. And that should be all the changes that I need. I do have an ID token write permission. So that is something that you also have to add if you don't already have that. Okay, so with these changes in place, we should be good to go to now run our pipeline without secrets because they are externally managed elsewhere. So let me go ahead and run our pipeline. So in order for me to run it, what I'll do is I will go ahead and create a pull request. So let me go ahead and let's see, I am here. So I am going to create a new branch called feature OIDC. And I am going to add all the changes that I just made. So everything in my GitHub I want to add. And I also added, I also need to add my AWS OIDC stuff. So let's see what that looks like now. Okay, so I am adding all of these files. Yes, I do want my getignore because I don't want to accidentally upload 100 different NPM modules. Alrighty, so now that I'm good, I'm going to go ahead and do some changes here. And I am going to commit all my changes. So make sure I don't forget any steps. Okay. And now I should be able to go ahead and open up a PR. Once I open up a PR, that should go ahead and trigger my branch workflow. So let's go ahead and see what that looks like. So here is my GitHub action. It should be running. It's called branch live. So again, this is going to conduct the equivalent of a Pulumi up command. So we'll give that a second, right? We now have the Pulumi auth step here. So we'll give that a couple of seconds to complete. In the meantime, I'm just gonna go ahead and check our Q&A. Okay. Looks like we do have a question on pros and cons of co-locating infrastructure code along with the application code. We do have some guidance around expanding on the pros and cons of that. We have a blog post, Zephyr series that can go into all the details and think about what are the recommended best practices for your needs on how to structure your code. So I'm going to go ahead and share that link as one of the questions here that came up, and hopefully that can give you a little bit of guidance. Okay, so let's see. Oh, everything looks green. That's good. That's what we want to see. So all of these was executed without having any secrets in my pipeline because I have OIDC for GitHub configure, and I also have a Pulumi ESC environment configure. So my Pulumi preview was successful and everything looks green. Alrighty, so this pretty much wraps up our very first demo. So I'm gonna go ahead and switch back to the slides and see what else we have. Okay. Alrighty, so for our second demo, again, we're taking an existing infrastructure pipeline and we're adding a lot of the more enterprisey and production-like things that we would typically see. So the next thing we want to add to our pipeline is policy. So we want to ensure that we have some sort of compliance, whether it be more of from a security standpoint, whether it be more from a cost perspective. All of that can be done with Pulumi's policy as code offering. We are going to merely scratch the surface here by adding a very simple package that works off the bat. It's called the CIS compliance package. We're just going to use it as is. So this is a good time for me to pitch in that we do have an entirely dedicated workshop around policy, and it's actually coming up on August 28th. So this is something you're interested in. I would certainly encourage you to sign up for that workshop. Again, we're just going to add a very simple compliance to our pipeline that works off the bat using Pulumi policy as code. So essentially what we're going to do is we're going to add a one-liner to our workflow. But before this one-liner can work, we actually had to add a policy to our existing infrastructure. So the way this works is, again, we have templates available for various policy packages. You can define policy or security rules. You can use Node.js or Python. Today, we're going to be using TypeScript just because that's what we've been doing all along. We're going to, in particular, use the CIS package. We're going to integrate that to make sure that our infrastructure is CIS compliant. There's a couple of additional things that you can do with policy as code. And one of the powerful things is like remediation policies. So say you have a policy to ensure that every S3 bucket has to have 4 different tags with certain metadata available. Well, if that's not the case, you can have a remediation policy that goes ahead and adds the missing tags to your cloud resources. So that can be very powerful at times. There is more of a business critical feature here, which is server-side enforcement. So for our case here, what we're going to do is essentially enforce things from the application side of things by adding a command to ensure that we are compliant. So I'm going to go ahead and switch over to my Visual Studio Code and go ahead and start working on my compliance package. So coming back to my screen, we are back in our infrastructure repository or infrastructure folder within our GitHub repo. And what we're going to do is add a package. And again, we already have many packages available off the bat. I encourage you to check them out, and then you start out with a package and then modify it to match your needs. The package that we are adopting today is called CIS compliance, and it's in TypeScript. So CIS is just a Center of Internet Security, I believe. And it's just some common industry standard best practices of what you should do in the cloud. So we'll give that a second to download and install. So now that I have that installed, I'm just gonna go ahead and switch over to that folder and then install any dependencies. So sometimes these packages can get outdated. So it's always good practice to just run an update just to make sure we have all the latest dependencies. So let's go ahead and take a look at our package here. Alrighty, so our policy pack is using AWS. And I can further restrict which services to apply this to. I know we're really only using S3, but right now I just have it, for all the services listed here. It's going to check all of these policies, make sure everything is good to go, and then give me a nice little, breakdown messages on how it is that we did against those standard policies. Okay, so with that, let's go ahead and see this thing in action now that I added a policy pack. So I'm just gonna come back up to my infra folder, and let me go ahead and add these dependencies in case they're not there already. Alrighty, so how do we check? Well, we use the Pulumi preview command. We pass it in another flag, which is your policy pack, followed by the name of my policy folder. In this case, it's AWS CIS. And I can go ahead and hit enter. So this will go ahead and check that my infrastructure is compliant. So we'll give that a second or so to run. And let's see. Alrighty, hopefully we get a green check. All right, here is our green check. All right, great. So now we just checked our infrastructure ourselves. So now we're going to go ahead and modify our pipeline so that this particular command with the policy pack check is done on our behalf. So we're going to go ahead and modify our workflows. So the first one here is going to be my preview. So essentially what I'm doing is I'm adding an additional line, which is by policy pack. You can have an array of these, so you can have multiple policies that you want to enforce. Because I have a new folder, I have to make sure I get those dependencies in place. And last but not least, I have my configuration variables up here. So that's really all I need to do to be compliant in my pipeline. And I'm going to go ahead and do the same thing for my merge request. So I'm essentially just uncommenting these just to save time. Alrighty, so we should be good to go. So what I'll do is I am going to trigger our pipeline, and the way I'm going to do so is just as we did earlier by creating another branch. So actually, let me go ahead and merge this branch, which I forgot to do because everything passed. Pull request, OIDC. Yeah, let's go ahead and merge those changes. Okay, so I should be able to go ahead and delete that now. Okay, so now that I have my OIDC changes in place, let me go ahead and check out main. Okay. And now I'm gonna go ahead and have another feature branch. Alrighty, give me 1 second here. Check out main. Oh no, I changed my branches before I should have. Okay, no big deal. Let me go ahead and fix this very quickly. So I am just going to go ahead and do a quick revert of these two, just so I can check out my changes. And because all I did was uncommon, so it should be pretty quickly to fix it. Alrighty, so now I'm going to go ahead and create another feature branch. I'm just gonna call it feature policy as code. I am going to go ahead and quickly come back. Now you get to see me do this twice. I'm just gonna go ahead and uncomment these lines. Okay, and I'll do the same thing for my main. Alrighty, there was one more down here. Yep, I want to add my policy pack, and then I have to add my environment variables. Alrighty, so we should be okay now. So let's go ahead and add those changes. I can just go ahead and add these as well, right? So these are all the changes I did. So I can make, and I can also use this. This is pretty helpful. Okay. Let's see, change my upstream, make sure I don't, and then do my PR. Alrighty, so this pull request, once I open it, it should trigger my branch workflow. And that's gonna have all these changes that I just made. Let me just make sure we're okay. Here, I'm just gonna do policy as code. Add it. Okay. Alrighty, so that's that. So now I updated my CI/CD pipeline to include my policy checks, which you saw me doing in the terminal, but now my pipeline is going to do so on my behalf. So let me go ahead and take a look at my actions. So here is my policy as code pull request. So this is going to go ahead and run, and it should now run with my compliance dependencies. My preview should also have some more information on as to whether or not I am CIS compliant. So I can go ahead and expand on this and just give it a couple of seconds to run. So while that's running, let me go ahead and switch over and see how we're doing here in the chat. I see a question. I'm sorry, I'm actually reading from the bottom, so I'm cutting the line in a way. We do have a link to the repository in the handouts tab that we're using. Alrighty, so my screen thankfully has another green check, so it's always good to see. So I was able to do my Pulumi preview command. Let me go ahead and expand on this right here. Yep, so here we see my policy compliant check. So that's exactly what we wanted to see. Alrighty, great. So now that I see that my Pulumi preview is compliant, I feel confident in my actual infrastructure code. So it's time to actually merge my changes. So once I merge this into the PR, again, it's going into my main branch. It's going to actually trigger another pipeline, right, which is my main workflow. So again, this is going to take maybe a little bit longer to run because it actually has to make the changes, not just tell me what the changes are going to be. So we'll just let that run while we move along with our demos. So let me come back to our slides. So again, you just witnessed maybe a quick overview of how to get policy as code integrated into your pipeline. The actual policy as code package has many more options and parameters and things that you can do to really tailor it to your needs. So again, I encourage you to, if you're interested, to sign up for the upcoming policy as code workshop that my colleague Josh will be running. Alrighty, so with that, let's go ahead and see what else we have. Okay, yeah, the next demo is drift detection. So drift is something that happens naturally when we are working with infrastructure as code. What this means is that our state definition versus what's actually in our cloud no longer match, right? So there's a mismatch between these two. So something that we want to be able to do is detect when this happens so that we can take the proper action towards remediating this. Ben just gave us a quick message here. He has to drop. So if y'all have any questions for him, I will route them over to him after our workshop. Alrighty, so sorry for the intermission. Coming back to our drift detection. We want to be able to detect when something is essentially out of the ordinary, when a change was made outside of a Pulumi program. There's many reasons as to why this may happen, right? Some of it may be intentional because you are in a disaster recovery phase and you just need to come in and make some changes and whatnot, right? So the idea is that you want to be able to detect when a change occurred so that then you can figure out proper steps towards remediating that drift. The way we do so with Pulumi GitHub Actions, with GitHub Actions and Pulumi is essentially we're going to add a new workflow using a cron job, and Ben tells me that cron jobs tend to make up something like 20% of all work GitHub Actions out there. So cron jobs are quite popular. We're going to be putting a cron on every 5 minutes, I believe, and then we're going to just manually trigger it because I don't want to sit there for 5 minutes. And essentially, this cron job is going to use the Pulumi GitHub action with two particular flags, and those are the ones highlighted here in red. So the flags are, we do not expect any changes, and we want to conduct a refresh. So the combination of these two flags will essentially detect drift on our behalf. So let's go ahead and configure our drift workflow, and then we'll go ahead and trigger it as well. So I'm going to switch over to my screen. So here we actually see my previous Pulumi up command successfully completed. So that's great to see. All right, let's come back to our code. Before I do anything, this time I'm going to check out main. Okay. Alrighty, so here we have our main, and what we want to do is create a new workflow, and we're going to call it drift.yaml. I am going to copy a completed version over just because in the interest of time, but let me quickly go over what I have. Alrighty, so first I am going to run this, or I would like this to run every 5 minutes. I'm gonna call this live because we are live. Alrighty, so our drift detection is going to go ahead and ensure everything that I have to find in my Pulumi program for my stack matches what I have. And if that's not the case, my action is going to essentially fail. So the key flags that really power this drift detection are expect no changes and refresh. Alrighty, let me make sure I didn't miss anything. So everything else looks pretty much the same. And let me see, my branch, yeah. So I'm adding a new workflow. I'm not really modifying any existing ones. Alrighty, this looks good. So let's go ahead and commit those changes just so that we can then trigger them. All right, so I'm going to add a feature called drift detection. I'm going to add all the changes. Oops, I can actually do this one. Add drift detection. Okay, and then I'm going to create a pull request with my changes. Alrighty, and here we go. All right, so now I have a pull request ready to go with my drift detection cron job. In this case, it's going to do the Pulumi preview. I know I didn't modify anything there. So I'm just going to go ahead and squash and merge this just so we can save a little bit of time. So now that I have this action available, we'll go ahead and let it run. So the first time this runs, right, we're not really expecting any changes to occur. So what we'll do, we're actually going to go ahead and trigger this change to happen. So let me come back to the slides, and essentially what we're going to do is, let me come back here. Okay, so the way we're going to trigger this is we already have our cron job that's running every 5 minutes. It's going to say, hey, is what's in my state versus what's actually out there in my AWS account what it's supposed to be. If that's the case, it's going to go ahead and pass. Right? My GitHub action is going to pass. Say for some reason a developer comes into the AWS console and they decide to rename one of the files that's controlled by the Pulumi program. That change is going to trigger a drift because the change occurred outside of the Pulumi program. So the next time our cron job runs is going to detect a mismatch. So what you see here in this diagram is what we're going to do next. So let me go ahead and switch back to my screen to show you that my drift detection action passed successfully. So what I'm going to do is, actually, I'll just run it now. So this should be good to go. Okay. In the meantime, I am going to go ahead and modify my S3 bucket. So this is the stack that we're working on. These are the resources that I have. So I can just go ahead and open the console directly to this resource from my Pulumi Cloud account. And let me just make sure this does run. So once this is done, right, there should be no drift. As soon as I modify that file and rerun my action, it should trigger that drift. So while this is running, just gonna go ahead and check the chat. See if we have anything there. I see Josh has gotten to pretty much all the questions here. Let's see. Yes, we do have policy as code for Azure, and I think GCP as well. Okay. So let's give that a second to run. All right, we are pretty much there. Cool. All right, we are green. So let's go ahead and mimic our person coming into the console and deciding that 404 HTML was a better name than error HTML. So again, this is a Pulumi controlled resource. So the moment I change it here and not in my Pulumi program, right, that is a trigger for drift. So I'm going to just manually trigger it. And now we should expect our workflow to fail. Why? Because this is now different from what I have. Alrighty, so again, this is going to take a couple of seconds to complete. So we'll just give that some time and I'll show you what that looks like. While this is running, I am going to go ahead and move on just because in the interest of time. So let me come back to my slides here. Alrighty, so this is what we're waiting for. So we're waiting for our workflow to come back and tell us there's a problem. Okay. So with that, this brings us to our very last demo for today, which is Pulumi deployments. So Pulumi deployments, it's really meant to enable you to develop and manage infrastructure CI/CD pipelines at scale. It's been specifically tailored for infrastructure CI/CD pipelines. It is part of, again, the Pulumi Cloud offering. I believe the individual free tier gives you 500 Pulumi deployments minutes to use per month, which to me it is more than plenty. There are multiple features within Pulumi deployments. One of my favorite ones is the ability to create review stacks. So that's what I'll show you here today. This works rather well when developing in different branches, because you can have an isolated, dedicated environment to test your infrastructure and application simultaneously. Once you're done with that branch, you can go ahead and merge the request, which will automatically bring down your stack. So essentially what we're going to do is configure a feature called review stacks. What that means is that the following will happen automatically via Pulumi deployments. You open a pull request, Pulumi deployments is going to instantiate a review stack. You make commits to your pull request, Pulumi deployments is going to go ahead and make those updates to your isolated environment called a review stack. Once you merge, it's going to go ahead and then destroy that stack on your behalf. This is particularly useful when conducting any sort of development where you don't have to worry about potentially lingering environments and resources after you're done developing that feature. Okay, so with that, I'm going to go ahead and switch over to my Pulumi Cloud account and show you how to configure Pulumi deployments. So coming back to my screen here, I see that in fact a drift was detected, right? Because I changed that file outside of my Pulumi program. So that confirms, where did it go? So that confirms my drift. Okay, so coming back to our code, let me check out main. Check out main. Alrighty, and now from main, I want to configure my review stacks. And in order to do so, I am going to, let's see, I'm going to go ahead and create a feature branch called feature RS. I'm also just going to have this ready to go and create a my branch. Okay. Alrighty, so now that I have my feature branch, I'm going to switch over to my Pulumi Cloud account. In particular, I am going to enable review stacks on my dev stack. Okay. So the way you do so is you do need a GitHub app install in your GitHub org. So in here, I already have that installed. You can follow the steps to configure the Pulumi GitHub app. I can show you very quickly. Great, it's gonna ask me for all my credentials. Okay. Alrighty, so here I have my Pulumi GitHub app configured, and you do have to give it access to either everything or just specific repositories that you are interested in. So let's see, CI/CD advanced should already be there. Let's see, what did I call it? Pulumi workshops. Yeah, okay. So it should be there. Alrighty. Oh yeah, here it is. That's the one we're working with today. So once that's configured, you can go ahead and deploy configure Pulumi deployments. There's a lot of different configurations here on how to do so. I have my feature RS brand. My Pulumi YAML is within the infra folder. So to enable review stacks, it's really this toggle right here. What that means is create a dedicated environment for every PR. Everything else we can leave as is. There's a lot more that you can do with Pulumi deployments. You can do like pre-run commands to add any additional dependencies that your pipeline may need. But for now, what we're interested in is that particular feature. Alrighty, so that's pretty much all I need to do. to enable the feature of having a temporary environment. So now let me go ahead and check my PR. Oh, I didn't actually create it. So let me create my my pull request, which should then trigger that environment to be created. Alrighty, so looks like that went through. Let's see. Okay, here it is. Here's my pull request. My pull request is then going to trigger Pulumi deployment to instantiate that temporary environment. So let me come back here. I think I saved my settings. Make sure everything is good. Alrighty. Alrighty, so that's pretty much what you need to do to enable review stacks. So we'll give this a second or so to deploy. I can also trigger this via the Pulumi Cloud directly. Like say I can go ahead and do an update. So I can go ahead and deploy that. I can trigger it via a commit, or I can also trigger it via the console, the Pulumi Cloud directly. Let me go ahead and push a, let's see. I want to just go ahead and push a commit just to, yeah. Okay. Alrighty, so I'm just gonna go ahead and push that just to make sure we're triggering the pipeline. Okay. All right, there it is. It's firing up. Let me go ahead and check here. My deployments. Yeah, so this was triggered by a GitHub push. So that's what I want. So this is gonna, again, take a second or so to run to make sure that my temporary environment is up and running, which means I can go ahead and test whatever feature I am currently working on. All right, so that is going to take, again, a couple of seconds to run. So in the meantime, I'm going to go ahead and switch over to our slides and see what else we have. All right, well, I guess that pretty much wraps up all of our demos for today. So again, we took an existing pipeline. We went ahead and added OIDC credentials using Pulumi ESC. We also use the Pulumi auth action to configure it with GitHub. We then added a policy using a CIS package. We conducted drift detection by adding a cron job to our pipeline. And last but not least, we configure Pulumi deployments with review stacks so that we can get those temporary ephemeral environments to test any change that we are actively working on. Okay, so this pretty much brings us to the end. Let's see. I see a couple of questions here. I think Josh has been doing an excellent job at answering them. With drift detection, like yes, as we saw, we created a Pulumi GitHub Action cron job to enable it. Okay, so we are pretty much at the end. I will give folks just a couple of seconds here to see if y'all have any additional questions. They do tend to take a little bit of time before they show up on our side. So again, thank you so much for your time. Thank you for all your questions. You will get an email with a survey. Please take a couple of seconds to answer that. It really helps us a lot. Other than that, feel free to drop. Thank you so much for your time, and I will catch you on the next one.